So let's get started with WebRTC. So one way you can sort of think of what WebRTC is sockets on steroids, and I'll be getting into why you would need something like that. So you've done game lab. Sockets are useful for real-time games, real-time communication. Sockets are pretty fast. So why would you want something that's even faster? And the main use case for WebRTC is for sending video and audio. So if you're having an application like Zoom or Discord, you might want to use something like WebRTC. And the thing with Zoom, WebRTC is going to be our first example of peer-to-peer communication. Although I guess like blockchains are also peer-to-peer communication. And I'll explain this. So imagine you're writing a Zoom, right, or Discord, and let's say someone is a client. They're streaming their video to their friends, and they're sending their video data to the server. Well, now the server is going to be sending all of this data, the exact same data, right? Because it's just video. It's not like mutating it or doing any of it. It's just relaying it. And it ends up sending it back to all the other people in like the Zoom room. Well, this is a lot of like wasted effort, right? Like, why send it all the way to the server only for the server to send it to your friends? Yeah, so why not just send it directly to your friends? This would be a lot easier than, or I guess a lot faster than doing a sort of roundabout trip. So answer to your question, why WebRTC? It's going to be a lot faster transport for your video and audio. And this is great because it's lower burden on the server, especially if you're using something like the Heroku free tier. And it's literally free. Doesn't have a whole lot of performance behind it. So you're not going to bring a lot of burden on your server. This means it's good for scalability. And an example, Discord actually uses WebRTC for whenever you do an audio or video call. So how are we going to use WebRTC? There's sort of two ingredients that we need. The first are something called servers. And the second is something called a signaling server, which is going to be built into your own application. So I'm going to explain what these two things are, and then we're going to do a live demo, and then I'm going to walk you through some code. So an example, WebRTC. Okay. So first thing, servers. There are two types of servers, stun servers and turn servers. And I'll be getting into this. But first, let's give sort of an example. Let's say we have Alice and Bob. Alice wants to send data to Bob, and again, we're not going to be going through a server. Alice is going to send it directly to Bob. But to send something to Bob, you need to know where the hell Bob is. You can't just send data off into the ether, right? But before you can even figure out where Bob is, like, where even is Alice? Alice doesn't even know where she is in sort of this internet world, right? Before you can figure out where Bob is, you should probably figure out where you are. And so this is what a stun server does. A stun server is going to it's going to tell you your IP address. It's going to do a couple more things, but that's sort of its main purpose. So Alice is going to be like, ask a stun server, hey, what's my IP address? And it's going to send a response back. And now that Alice knows her IP address, she can communicate with Bob. It's going to be a couple more steps involved, but she has her IP address and send it over to Bob, and then they can start communicating. So a stun server doesn't just give an IP address. They can do a whole complicated process called NAT Traversal. This is why we don't just use like the address website. What is my IP address.com? This is why we have this whole stun protocol. And sort of the way you sort of explain NAT Traversal is, okay, so when you connect it to a network, let's say like MIT Secure, you have something called a public IP address and a private IP address. This is called network address translation. This is called NAT. And so when you are communicating to like google.com, they're going to see you have a public IP address of And basically everyone connected to MIT Secure will have more or less the same public IP address. But within the MIT network, you're all going to have different private IP addresses. So you have a private IP address for within the network, the public IP address outside the network. Now, when Alice and Bob are communicating to each other directly, they need a way to sort of get beyond this like whole translation layer. You can sort of think of this NAT as sort of like a barrier, and there needs to be a way to navigate this barrier. And NAT traversal is the process of collecting the relevant routing information to get around this barrier. Now, you won't need to do any of this stuff yourself. The Sun server is going to do it for you. But that's why you need the Sun server. Otherwise, you just wouldn't be able to send data directly between each other. Side note, like when you're doing like normal client server communications, usually like the server is set up so you don't actually have to do all this stuff, right? You can just connect to it. But when you're doing peer-to-peer communication, like through WebRTC, you do have to worry about these things. So now what is a turn server? So with info from on servers, you're usually able to send data to peers directly. Like let's say maybe 70 to 80%. I don't know if that number is accurate, but most of the time it's gonna end up working. But sometimes network configurations make NAT traversal impossible. So sometimes people have like a firewall, they're working on like some sort of company Wi-Fi, company network, company VPN, that's gonna sort of end up blocking these peer-to-peer connections. And this is basically a whole bunch of messy network things that we probably don't want to learn about because of our sanity. And it's going to make this whole NAT traversal impossible. And so turn servers are going to act as relays in this case. And basically, turn servers are our backup. If stun, like connecting to the information from stun doesn't work. So turn servers, again, they're just relays. So this is going to look like our normal server model. So we're just going to send data directly to the turn server, and then it's going to relay to Bob. And now you're wondering, if we end up having to rely on turn servers anyways, why not just build it into your own web application? Like, why are we doing WebRTC at like 20% of the time we have to rely on turn? Well, other 80% of the time you don't, right? So you're still saving a lot of power. And it's oftentimes it's going to be easier to just have like a dedicated turn server rather than having to host all this data flowing to your web application directly. And the other thing is often you can get like API to provide a directed or a dedicated server for you to do these things. So you won't have to worry about it. Okay, so the next component is a signaling server. So we need a signaling server. Again, the signaling server is built into your own application. And we'll be walking through what I mean by this in a second. So we're going to walk through the code. We need the signaling server for clients to form the initial connection. So for Alice to be able to directly send data to Bob, she and Bob need to do a bit of communication beforehand to set everything up. This is facilitated by a signaling server. And once everything is set up, now they can communicate directly. They can send data, they can send audio, they can send video, everyone's. So I'll be giving a live demo. Now, this website is very ugly because it doesn't have to CSS, but that's okay. So I'm going to open 2 tabs. And as you can see, I'm sending data from myself to myself. This is not very exciting, but this is none of this audio video data is going through the backend server. This is all going from my laptop to the internet and then directly back to my laptop. And for a bit of fun, I would like people to try joining at weblab.is/RPC demo just to see how many people we can see that to join this Zoom call, let's say. Remember, it's web.lab.is/RTC demo. And once you're in, join this room code. Yes, yeah. It is J4XX all caps. Let's go. And again, none of these audio streams are going through any sort of Heroku backend server. Okay, these are all going directly from each other to each other. And eventually, this is going to cause someone's laptop to lag not because of load from the backend server, but because there's too much audio data or video data in the website itself. It's going to crash someone's browser, but hey, it's working, or it was working. Some people disconnected, I think, but. Let's keep going. I just want to see. This is a fun experiment, guys. Oh, see that lag? Oh, the other thing is you can also send data to each other directly. So, and in theory, I just sent every single person who is in this call like a HRLO message. Okay. We should probably get back to actually teaching. Okay, so that's it for the live demo. But now we're going to be walking through the code. I guess you guys can feel free to Zoom each other in lecture if you really want. Maybe pay attention. I don't know. Okay. So if you want to, feel free to clone from web.lab.is/RTC code, but I'm going to be walking through the relevant parts anyways. Or if you want to look at the example code later on, if you want to include something like this in your own app. But let's get started. So we have the WebRTC application, which I modified starting from the starter skeleton. And we're going to be starting off in the backend because it's actually going to be really, really simple. So going into our API, we're going to have two API endpoints, create room and join room. So create room is used to host a room. So you notice at the start, I clicked a ugly looking host button to get a room code to send to everyone. And what we're going to do is we're going to take the requester's socket ID. We're going to generate a random string for a room code. And then we have the socket to room map. So we can map socket IDs to rooms and a room to socket map. So we can map rooms to a list of socket IDs. And finally, we're going to send the requester the room code. Next up, we have join room. So again, we're going to get the room and the socket ID from the request body. And if they're both defined, we're going to look up the list of current sockets that are connected to that room. And we're going to send that over. Basically, when you host a room, you want to get a room code. And when you join a room, you want to know the socket ID of every single person in that room. This is so we can start our signaling so that we can have a WebRTC connection. But again, key thing to remember, when you join a room, you get a list of socket IDs. And next, we're going to be going through the signaling server. I know it sounds maybe a bit fancy, but it's just a couple lines of socket IO. Key thing to note, here we comment out this old socket.disconnect. This is what allows us to have multiple copies of the application running in the same browser. Otherwise, you would only have one socket at a time, and they would be disconnecting from each other, and you wouldn't be able to test your application. This was the cause of a bug when I was writing this, just pointing that out. But here's how the signaling is going to work. And it's very simple. Sometimes we're going to receive a signal user event, and it's going to have some data. The data is going to have a field 2, which is going to contain the socket ID of the user you want to send this to. We're going to delete data to 2. We're going to change data from is going to be the socket ID. And then with io.2, we're going to send this data directly to the person you want to send it to. So basically, when we get a signal user message from Alice, data to 2 is going to be like Bob. And then we're going to take that data and send it over to Bob. Does anyone have any questions about our signaling server? So that's all the signaling server is. Getting into the client code, there are a couple components. We can look at client socket and connection. So first off, we have this class RTC connection. This is going to manage our WebRTC connection. We're going to ignore this for now. We'll get into sort of the details of forming the WebRTC connection next. But the main important thing that we export from here is this connection object with a whole bunch of different methods and some different variables. Event target, ignore that for now. This is going to be something we use to communicate to our actual React portion of our website. Here is going to be a dictionary of these RTC connection objects. Stream, ignore this for now. This is going to hold our video data, like our local webcam data. And remote streams, this is going to hold our remote webcam data, or the remote video data that's coming in. So now moving on to client socket. So we're going to be there's going to be 2 sort of socket IO things we're doing. So when we get a message signal from user, we're going to give this to the connection object over here. It's going to handle the signal depending on whatever the data is. And then we're going to expose this signal user function, which is going to emit data to a user. And that's all we need for the socket IO part. And remember, socket IO is going to be going through the server, and we're only using socket IO or WebSockets for the initial formation of the connection. So looking at our connection, we have these 4 methods. So first up, handle signal. First, we just do some data validation. If there's no from field, we don't know who the hell sent our signal, so we're going to ignore it. Now, if we don't have a RTC connection to the peer this data came from, we're going to start creating a new connection. So we're going to create a new instance of our RTC connection class. Set it. We're going to start this connection using an RTC configuration. I'll get back to this RTC configuration in a second. This is somewhat important. We're going to tell them who we're forming the connection to. And this true, we'll get into this in a bit. And then this piece of code is a bit complicated, but this is what sort of takes our video data and sort of plugs it into the RTC connection. And so what this is doing is, if we get a signal from a user, overall at a high level, if we get a signal from a user and we don't have a WebRTC connection to them already, we're going to start a new connection with them. On the other hand, if we already have a WebRTC connection with them, we can tell this RTC connection to handle the signal and sort of set up our WebRTC connection. And I think this will start making more and more sense as you go through our RTC connection class, but this has a lot of connection details, so I don't want to get into it yet. Next, we have connect to peers. So when you click the join button, we're going to receive a list of socket IDs, and we're going to connect to every single socket ID, or not the socket, but every single user through their socket ID. So for each one of these, we're going to start a new connection. And if our video is enabled, we're going to add this video data to that connection. That's all I'm just doing. And I know I promised I would explain this RTC configuration over here. So to use WebRTC, remember, we need ICE servers. And so here we have a list of sort of free ICE servers or publicly available ICE servers. We have something from Open Relay. We have some stun and some turn options. If you were to use WebRTC in your own application, you could start with these publicly available servers, and you can find a pretty large list of them online. If you wanted the highest quality, you might want to get your own dedicated turn servers at least. And you don't want to set that up yourself because that would be a pain. But I know, for example, the Twilio API allows you to have your own turn server. So if you want to do that, you can do so. And I've used the Twilio API in the past. And then we have a handle message function. This is just for the very simple chat that we had in the app. And then we have a send function, which is going to just broadcast a message every single peer. Okay, but getting into our RTC connection class, so we have a constructor. We're going to start off with we need a peer ID, we need a peer connection, we need a data channel, which I'll explain in a second or later on, and then is host. So in our cases, a host is going to be someone who is receiving the RTC connection. And if you're the client, or like basically not the host, if you're joining, you're going to be the person who's initiating the connection. And we'll be going through that in a second. So when we start, the first thing we're going to do is we're going to create an RTC peer connection. So this RTC peer connection is basically an API within your browser that is going to handle most of the WebRTC connection stuff for you. But you do need to give it a bunch of data. Specifically, you need to give it the list of ICE servers over here. So it can start making requests to the ICE servers, so you can get your stun information back, and then you can go and connect the Bob or whatever. So first thing we're going to do, we're going to make this RTC peer connection object. And we need to set up a bunch of different event handlers for this RTC peer connection. The first one is on ICE candidate. So this peer connection is going to start making requests to ICE servers, and whenever it gets a result, it's going to trigger the on ICE candidate event. And when you receive an ICE candidate, this information is basically your IP address, right? You don't need the IP address. Bob needs your IP address because Bob wants to send data to you. So you need to tell Bob, you need to signal Bob, hey, here's my IP address. I want to talk to you. And so that's what we're going to do using our signaling server. So we're going to signal to Bob, and the payload, the data we're going to send to Bob, is the ICE candidate we just found. That's why we have ICE event.candidate. Does anyone have any questions about that? Okay. So next we have some differing options based on is host and not is host. We're going to be doing this portion kind of briefly. We're sort of getting into a lot of like weeds into how the WebRTC connection is formed. So we're just going to sort of skim past this. But basically, once you signal to Bob, hey, I exist, I want to talk to you, we're going to go through this whole sort of negotiation process. And so what Bob is going to do is he's going to send you a negotiation request, and then you're going to do something called creating an offer. And in this offer, we're going to specify what kind of data we want to send. So by default, we can always send like text or JSON data. And then we can also specify if you want to send video and audio data. So we have offer to receive audio 1 and offer to receive video 1. If these are both 1, our offer is going to be like, hey, we want to receive these things. And then we're going to do this local description created method. So we need to do something called set local description. And then we signal Bob using our local description. Our local description is basically our IP address. It's not the same as the ICE candidate. Don't worry about it. This is just the process of setting up WebRTC. If you were to do it yourself, you would just need to basically do the same thing. You don't need to exactly understand what's happening, but you can if you read like documentation. And basically, most of this code is doing all these WebRTC handshake things. We're going to skip most of them. The important parts are here. So this peer connection.onTrack, what is this? This triggers when you have connected to Bob and he has enabled his video and you have received his video data. Once, like the first time you receive his video data, roughly speaking, this on-track event is going to fire. And when you do this, you want to store his video data, which is going to be in event.streams0. So you want to store this in your connection object so you can display his remote video stream. So that's what we're doing over here. And then we have this weird connection.event_target.dispatch event. I'll be explaining how we communicate between our connection object and our React next. But that is what this is doing. And then finally, we have setup data channel. So what is data channel? So we have been talking about a lot of like video and audio stuff. But you can also send text data. And to do that, you set up a data channel. And you just have a bunch of different handlers. But the main one is data channel.onMessage. And we're going to send that to be received message. Here. And that's going to do connection.handle message. So basically, whenever you receive text data from WebRTC, whenever you receive text data from WebRTC, the data channel on message event is going to trigger. And then you can call receive message and you can do things with your data. Okay. Now, if you want to, you can look through this yourself, but again, this is a lot of sort of weeds of how the WebRTC connection is formed. So I'm not going to go through all of it because it's not super important. But at a high level overview, I'd like to give you the most important tidbits of forming our WebRTC connection. Now, the last thing we need to do is we have our connection like object over here, but we need to actually like communicate with our like React app, right? I mean, this is running on the client, but like we haven't done anything with React, right? And at the end of the day, people are looking at our React. And this is where this event target comes in. Event target is sort of like an event, not a handler, but an event dispatcher. And I'll show you what this means. But we're going to use our event target to communicate with the React app. So if you go to our components, we look at our video chat, and we look at our use effect. This is going to run when we create the video chat component. We have our connection.event target .add event listener new video new media stream. So what's happening here? Basically, whenever we get a video stream, we're going to dispatch a new event to our event target object. Right, we're dispatching this event. We're going to give it a custom event object that we create. Custom event is an event that we are using. So like when you're doing native JavaScript, you're going to have a lot of events for like when you click a button, when you submit a form. Custom event means it's not related to like a browser, it's used for our own code. And we're going to give it like the event stream. And now we can give it this event handler. And we can listen to our event target. And whenever we receive a new media stream, we can do something about it. Which is great because otherwise there would be no way to connect to our React app. So whenever there's a new video event, our new media streams function can run. And when this happens, we can do set remote streams, and we can add a new video stream to our list of video streams. Does that make sense so far? So I guess like the key thing to remember is if you need to communicate between like, you need to communicate between sort of an object and our React code. A great way to do that is through this event target / event handler. And then finally, looking at our actual like HTML component, we have this small video component over here that we're going to pass this media stream into. Our media stream is just our audiovisual data. We're going to give it our local media stream because we're at the start, we're displaying our own webcam. And then finally, for every single remote stream we have, we're also going to create a video stream. And that's really all there is to it. Does anyone have any final questions? Or any part? Yep. So you can use it to directly send data. I mean, I know I said that already, but use cases for this, for directly sending data, there might, I guess. I don't know any off the top of my head, but there are. It's just sort of like there would be like very specific use cases, if that makes sense. Like a couple years ago for fun, I made like a sort of game website where like all the logic would be hosted on the client end. So like every person participating in the game would like use WebRTC to connect to like a host. The host would be like someone's browser. It would view all the data and then it would send it back to each of the people in the game. Why would you do this? There's no reason to do this. It's unnecessarily complicated, but just for fun. So I guess to answer your question, if there's any time you have a bunch of data, it's like very specific, but yeah, I can. Any other questions? No, so there are other methods. I don't know exactly what they are for this. Because I thought Web3 I started like a lot of like blockchains are like all blockchains have to be peer-to-peer, right? But they're not going to be using WebRTC most likely. They're going to be using their own things. And I guess like the most important part of that is they have to do probably also have to do like the whole NAT traversal process. But WebRTC is nice because it does most of that for you and it's built into the browser. And then this is you don't even have to use it when you're in the browser, right? Because like Discord can use it. So I guess in some sense it's like the easiest way to do a peer-to-peer. Any other questions? Okay. I guess that's all we have for now.